Why is it sharing this? There we go. All right. So I believe we are recording, and let me go over my housekeeping things real quick. Okay. Are we recording? We have the system set up. I'm sharing the right screen. No in-person attendees, post link in Zoom chat. All right. So I think we are good. So let me just quickly share the materials with you in case. Awesome, Hari. That is pretty much something that we want to cover a little bit in more depth with a use case. All right. Welcome back, everybody. This is the workshop series NLP for All. And today we'll be discussing how regular expressions play an important role in natural language processing, in building search queries, in pre-processing your data, and ensuring that the corpus or data set that you create for your downstream NLP tasks can be made leaner, cleaner, and more structured, right? So most of our materials live in the GitHub repository, NLP-speech. And if this is the first time you're attending a workshop with us, most of our workshop materials are linked in a little calendar or a table down here. Specific links to our materials will be listed next to the date and workshop time. And if you click on a link to Notebook, it should take you to the Jupyter Notebook where today's material lives. And if you'd like to follow along, you can click on Open in Colab to open your own instance of the Jupyter Notebook, where you can make your own edits, you can play with the code, and remember to save your work at the end of the meeting so that there's an instance of the code that you have. All right, so back to my instance of the code. First up, let's talk about what regular expressions are. So when we discuss regular expressions, they're a specific combination of symbols and characters. Many of these special characters carry meaning when they are housed inside inside a regex string. The main purpose is to perform an intelligent and fast task. And we are doing this for the purposes of pattern matching. All right. Now, the main cool thing about regular expressions is they have Unicode compatibility. What this means is if you're building your regular expression for, say, searching through Spanish text or Malayalam or Hindi or any language that doesn't use the standard ASCII Roman letters that we use for English, all of them can be effectively read by the string matcher, and you can work with multiple languages. You can do search involving scientific symbols, and you can use the different scripts all around the world. Now, we combine regular expressions with other tools, and the other natural language processing tools that we might combine it with can help us with effective text-based searches or tasks, such as scraping. If you have a lot of text that's been grabbed from, say, 10,000 websites, there is information inside all of this corpus that can help you get to the main content from these websites. For example, it helps us with filtering. We can also perform advanced search and replace in text processors and spreadsheets. So you can use regular expressions for building your searches in Google Docs, in Google Sheets, Excel. It's also a feature in most text editors like Sublime, for example. And so with the use of regular expressions, it opens up your ability to search and process text with a higher degree of efficiency, and more importantly, with a very low computation overhead. So before we pass on a massive code base, a massive data set to a large language model and eat up all of our compute time, it might be worth it to structure the data a little bit, make it lean, get rid of unnecessary things, and improve the efficiency of your task. All right. So what what are some simple use cases for regular expressions in a in a domain agnostic kind of work. At this point, I'd like you to have this question in your mind, and in case there are use cases that you think are applicable to your research, you can share them in chat. Or if you're wondering what are the ways in which you can use regular expressions to search and query the kind of text or the kind of documents that you work with, it's also a valid question. Please do share it in chat, and maybe we can discuss it towards the end of our workshop. All right. So very, very brief 3-line history for what and why of regular expressions. First, there was a need for string matching and editing at a mass scale, and regular expressions were developed as early as the 1950s, and they've been ongoing. There's been new strings and new tags that have been added over the years. Right. Then regular expressions first made their appearance as an advanced function in the Perl language, which is one of the earliest natural language processing engines. And at this point, they became a core feature of any kind of text processing. And to this day, they are very important for many pre-processing steps. Sometimes they're working in the background in many of our applications, and we don't even see it on the user front. Right now, at this point, of course, Regex has also been subject to a lot of amazing memes. Here's XKCD explaining how and what we can do. And right here, there's 200 MB of emails, and someone's looking for something. And yeah, there you have a superhero swooping in with regular expressions to save the day. I love this meme. And now that we have a little bit of understanding of what the use cases for regular expressions are, we're talking about search, we're talking about finding and replacing strings, we're talking about extracting specific subsets of a large data set. Next thing is, while we're building and learning about how regular expressions function, we might need to ensure that we have our terminology in place. Right. So first up, when it comes to regex, we'll be looking at patterns. This is something that is constructed by the user so that it can be matched across a large text, a large document, right? So this would be an example here. We're looking for the characters A and D, followed by a bunch of other things that we are more open about. Next is strings, right? So this is a test string that we're using to match the pattern. So this could be 1,000 characters, it could be 100 characters. It's essentially the thing that we're going to look into. Next, we have characters, which are the letters, digits, or symbols, the individual building blocks that are part of our pattern as well as our string. Next, we have within characters, one of the most important types of characters that we'll be dealing with are letters, digits, and alphanumeric character sets. So for example, if we're looking to remove or eliminate all special tags and characters in our document, we'd want to we'd want to filter our search with the lowercase and uppercase alphabets, as well as the 0 to 9 numbers. There are, of course, other shorter ways to express these character sets, and we'll be looking at those today as well, right? Now, important thing to remember is that the special character underscore is treated as an alphanumeric character in many regular expression engines. And so for programmatic reasons, and if that's something that you want to eliminate, there are ways to ensure that your character set's only looking through characters and not any kind of special character, right? Next, we have meta characters. And of course, here meta implies special symbols that regular expressions that any regex engine is going to interpret non-literally. And so these are things that we need to use in order to make sure that our expression is being read correctly. Now, if I look at the previous examples here, we see the clean star over here. We also see the square brackets. These are all characters, but when we enter them in a regular expression, they're going to be treated as meta characters. They have a special symbolic meaning to the engine. And if we want to use them literally, if in my document, I want to search for square brackets, I have to make sure that I add a escape slash before them so that my engine knows to look for a literal square bracket instead of interpreting it as a special character, right? And I have some examples below to make sure that this is properly explained. Now, some other special within the scope of meta characters, we have some special patterns that might be important while framing your regular expression. The first one is a space. Now, think about English. In order to put words together in a sentence, one of the ways in which we do it is we add the bunch of characters that make up a word. We add a space followed by another set of strings, another set of characters, which are word number 2. And as we build these words together, if we wanted to simply extract all words in a particular document, the /s is a meta character that might be important to grab all the words that are available in our document. Right, and think about any word search that you perform with a document processor. When you enter this information, I mean, you can compare adding a space character with your keyboard versus adding the /s in a regex compatible document editor, and see if you get the same results or different results. All right. The next important character would be the new line, which is /n. Again, if you're looking through your document and you'd like to parse your document by lines, then one of the ways in which we can do that is is by looking for the new line character. Right now, next is a wildcards, and a wildcard is simply a meta character that denotes a specific type or quantity of characters. So the two types of wildcards that I'll be looking at today, and I'm sure there are more, is the dot, which a regex engine is going to interpret as 1 or more, and the star, which is going to get interpreted as 0 or more. So if you are looking for example, for a word that has 2 O's in it, for example, look, the word look, and you're also interested in extracting all words that have 1 O in them, for example, the word lot. One of the ways in which you can do that is specify that you're looking for a word which has O's in the middle of it. And if you're not concerned with how many O's, then we can use the dot, which implies 1 or more. And that's one way to go about it. Now, this will ensure, if you use a dot versus a star, one will ensure that all of your results have at least 1 O in the word. And if you use a star, then you'll see that you're not going to have any O's in your search results. It'll simply return all words that it encounters. All right. So the next thing meta characters that we might want to be familiar with are the brackets. Primarily, regex uses 3 kinds of brackets that the user can use to specify different quantities. The first one is a curly bracket, which functions as a quantifier. We add numbers inside them. I'll explain how they work. The next type of bracket is a square bracket, which is our way of providing a list of characters that we want to see together, and we're trying to search through. So an example or a use of the square bracket would be for searching for Roman letters. So in the first instance of the square brackets over here, our engine is going to look for any character that's between A and Z. And you'll notice that there's another meta character here, which is the hyphen, which is helping us provide the upper and lower limit, right? And the third kind of bracket that I'm not sure if I'll have time to go in detail in would be the round brackets, which we use to group characters together. Now, a simple example here, if I want to look for all the words in my document that have the characters AT together. So for example, cat, bat, mat, attention. So there are lots of words, and I'm interested in looking for all words that have the characters A and T together, but I'm not concerned with anything that's around the A and T. I can group these two strings. I can group these two characters together with round brackets, and now my search engine is going to make sure that it's looking for an A and T together. And because I have grouped them together, it's going to be possible for me to use this group for further processes. Finally, something that like I found super useful would be the anchors, which are used to denote the start of the line and end of the line, right? And so if you're looking for the word cat, but you're only interested in the word cat when it appears at the beginning of a line, you can use the anchor. You can use the start anchor in order to ensure that your search only returns the word cat when it starts a word. And if you're looking for the word cat, but at the end of a line, you can use the question mark meta character in order to ensure that you're only searching for instances at the end of the line. So now think about it. If you had a data set with millions and millions of lines, it would be very important to make sure that our regular expression is built with some of these efficiencies kept in mind. And so we've got lots of options, and there are lots of resources that can help you build a good search query. And I'm trying to, these would be some of the simple meta characters that we can practice with today, so that in the future, when you're ready to build your own expressions, you have some of the basics in place. All right. Now, having said all this, we have lots of ways to do advanced search. We have lots of resources out there. Why would we want to use a technology from the 1950s? One, we're already using it. It's just a lot of this happens in the back end, so we might not be able to explicitly see it or call it. Two, as far as advanced searches are concerned, if you are looking at working with a lot of data and you are interested in building a nice data cleaning pipeline for any work that you have, it could be looking at a corpus of PDFs from PubMed. It could be looking at all the emails that you've ever sent out. It could be any corpus that you'd like to privately work on and you're not interested in sharing that information with the world. It's advanced search with low compute need is something that can really go a long way to get you started on an NLP task. Two, when you're building search pipelines, and they contain regular expressions. The important thing is if we encounter a pipeline in the wild while we're working, if we're borrowing someone else's code base to work on, it's very good to at least have an intuition of what these regular expressions are that are being used, what they're supposed to do, and what they're actually doing. So consider this a means of looking under the hood, even if it's not something that you may directly want to construct. Third is it's a great search option in most popular editing platforms. And so if you know how to use regular expressions and you're working on your dissertation like me and you want to change 50 things at the same time, it might be a good idea to use something like regular expressions instead of a simple find and replace. So just a small new learning. And the hope is that if you have a special use case for editing, it will open up your search and find and replace kind of actions into a more streamlined method. And last is, think of it as an exploration of whether the project that you're working on actually needs a large language model or not. So if you are considering using an LLM to do data cleaning, to do data scraping, if basic regular expressions can give you good and fast and clean results, it might be worth considering at what point you'd need the intervention of um, okay. Of course, regular expressions are have their own issues. It's if the deeper one goes into constructing regular expressions, the more inefficient one's work life might be. So it might be worth it to make sure that we understand our use case before considering whether we need a regular expression engine or not. All right. So next would be the how. So far, we have the what and the why. And let's consider some example uses for how we can build our regular expressions. What are the tools available to us in order to improve our use of these? And are there ways to validate our regular expression before we send them out into the wild? Now, personally, I use two main tools, and I think these are fairly popular. First is using a platform, online platform like Regex 101. Let me show you what it looks like. All right, so here is the portal. You can essentially, it asks you to insert your regular expression. You can provide it with a little test string, and you can see, you can assess if the search terms that you wanted to search for are correctly being identified or not. So just as an example, let me add my search term. I want to look for the word for any word which has A and T in it, start with the C, and I want to make sure that they are at the beginning of the line. So let me add some. All right, so I have some options. And the next question that I want to ask is, what is this doing what I think it's doing? So as soon as I add my regular expression, I get an explanation of my code right here. So in case you forget what special characters, meta characters, strings do, you immediately get a simple explanation over here. So here, it's going to assert the position at the start of the line. It's going to match the character C with, it's going to match C, and it's going to look for a group AT, right? And now, if I look at this space over here, I can see that it's highlighting the results that it's searching. And if you look at the match information, you'll see that if I search for this term, for this regular expression in this test string, I get one match, which is the word cat. And I'm also able to save a group, which is 80. Now, let me change my search term over here. All right, so I'm saying, I'm asking my regular expression to look in the beginning of the line. I'm asking it to not be concerned with anything that it sees before A and T, and simply go ahead and search and return the group AT for me. So again, all of the explanation for my regular expression is provided over here. And as you saw, if you make an error, your error will also be searched, will also get listed over here. So this would be a more, I think, a maximalist approach to how to set up your regular expressions. The easier, simpler version, which I'm sure many of you might have also tried out, is simply brainstorming with an LLM. So all we need to do is open up ChatGPT, ask it to provide us with a regular expression that can do a certain kind of text matching for us, and simply validate its output. So I strongly recommend the brainstorming option in case your regular expression needs are more complicated, and depending on your unstructured data. Right. So the next question is, where all can I use a regular expression? What's the scope of this tool over here? So first is, of course, you can use it in your command line interface if you're writing a bash script, or you're simply you simply opened up your terminal and you're interested in getting a search hit. The simplest way to do it would be to include to use it with grep, which will look inside your string and match it to a regular expression that you provide. Here's an example of me looking for for numbers, 10 digits separated by 2 hyphens, containing hyphens. And here I have all instances of phone numbers that have been formatted in this specific way. Next, of course, regular expressions can be used with Python. In order to use them with Python, we would need the RE library. I'm sure in case you haven't used it before, the Regex library in Python has a bunch of functions that can match and return and group things differently. In the example here, I'm using the function I'm using re.match, and if we just read through the code real quick, you can see that it requires a pattern and string. And when executed, it tells me if something is a match or if something is not a match, right? So here it's the value that you'll get is Boolean. All right. Now I've just simply provided the function here. We'll have to execute the function to get some examples out. I'll do that in a second. All right, so the next thing is just some more examples. I've tried to keep things as simple as possible, but if you have more complex use cases, I'd love to hear about it, and maybe it's something that we can discuss. So the next, in the next example, I've simply used the function that I defined earlier to return a bunch of matches for me. So here I'm looking for a word that contains the strings over here. I'm looking for anything that starts with a T, has a bunch of any word that there's a T and followed by a bunch of other characters. So we've got, and in this case, I have 3 examples. You can try and see what output you get when you search for this pattern in this string. And if you're interested in more in a further explanation for what this specific pattern does, I recommend simply taking it out, putting it in our Regex 101 engine, and reading up on the explanations. All right, so if you're looking for letters, digits, and alphanumeric characters, we have a couple of examples here. We can also search for spaces and new lines. And there are some other bracket options in order to search for a certain number of instances of our string appearing. Right, so there are examples of how to use curly brackets right here. I've also have some examples of round brackets and anchors, and all of the output is printed over here. And before I proceed, I'll just give you a minute to consider some of these examples. And if there are any questions, or if there's something that you'd like to share, please feel free to do so in chat or by unmuting yourself. Okay, so in case all of your data science work happens in R, R also has its own libraries for working with regular expressions. So this little code box here just allows me to run R on Colab Node on the Google Colab platform. And the actual code is over here in the next code chunk, where I'm calling the grep, or you can use the grep or grepl library depending on your use case. And if we look at the syntax, it's quite similar to we're defining a variable that contains our string of interest. We're defining another variable with our pattern, and we're using a grep to assess if the pattern and text are matching. And every time it matches, it's going to return the match for us, right? Now, in this example, I created a list with 3 strings, and the strings that are getting returned are the ones which contain the numbers and hyphen, a combination of numbers and hyphens. All right. Now, finally, in case you're used to you need advanced Google search, Google search along with operators also accepts regular expressions into the search, and it's not something that I have widely used, but I know that it really can help streamline your search engine requirements. And so if you're using regular expressions with your Google search engine, the thing that you need to make sure is that your regular expression is housed inside slashes, right? And this allows the engine to interpret any text that is enclosed in these slashes as a regular expression. So as an example, I wanted to go through the regex subreddit, and I wanted to look for posts and comments that have digits in them. So anything that's looking in which a user has asked about how to use zeros or ones or twos. And so I set up my regular expression within angular brackets right here, and I use the operators cite and after to specify my engine to look through Reddit and look through the regex subreddit and only return queries that are after 2020. So again, if you'd like a couple of seconds, I invite you to open up google.com and try searching for a specific regex string and see what the output looks like. Okay, so this brings us to today's group project. This is just a simple task that I set up for all of us to try together. The main objective here is to look at a corpus of completely unstructured data and see if we can use regular expressions to improve readability, searchability, and add a little bit of structure by filtering out the information that we might actually need. So a very, very popular example across many classrooms and demos is looking for fraudulent emails, looking for spam, and and that's a task that we'll consider today. Now, here we have a fraudulent emails data set that I got from Kaggle. It's an open source corpus. My primary task over here is to actually read through or some of the text that is housed in this data set and extract parts of the email. So I want to look at the email at each of the individual emails that have just been dumped as text, and see if there's any way that I can extract parts of the email body, right? And some of these tasks could include I might want to capture the email ID of the sender. And if you have encountered if we consider an email ID, it usually contains a domain name, it contains a @ symbol, and it contains a user name. So there are predictable patterns that tell us that a long string is an email ID. So that's something that we could use. We might want to specifically read through the subject lines, because if we have billions of emails, sometimes identifying fraudulent emails is as easy as simply looking at the subject line, right? And then third is we might want to actually look into the email text in order to assess if the text contains something suspicious. Now, consider the pipeline over here. If you're planning to train an instance of a machine learning model that does fraudulent email searches for you, this would be a great way of basically setting up your training data. You could, if the question of interest that you have is, can I predict if a given email is fraudulent just by looking at the sender's email ID? Can I predict if an email is fraudulent by simply based on the text that is contained in the subject line? Third is, do I get better results if I am capturing the data inside the body of the email itself? So this would be a base task. It's something, if you're setting up your own instance of a filter from scratch, by using Regex, you can use an existing popular data set in order to create training and test sets for 3 different use cases. All right, so the first thing I'm doing is simply calling calling the corpus and splitting my unstructured data set by new line characters. And if you run the next command, it simply gives you the first 300 lines of your corpus. And I invite you to take a few minutes to simply read through what our unstructured data in this case looks like. So you'll see that there's colon, there are certain words that seem to contain certain information. There's a specific way in which email IDs have been housed. There is a text-based way to identify the subject line, and where does the body of the text live. So please take a minute to just look over the text that we have got in its unstructured format. And then the next thing that we'll be going into is trying to understand what it is about a spam email that makes it stand out as a suspicious piece of text. Okay. I hope that you've had a chance to look at the corpus over here. And this is, of course, a very old corpus. And so we've got references to Nigeria and princes. I think if you're from India like me, you may have noticed that the primary spam and fraudulent email scams that are running right now involve informing someone that the police is after them or the IT department is after them, and the email contains some kind of a reference to a crime that the person has committed, and the language tends to be very convincing, and people tend to fall for the scams even before realizing where the email is originating. So of course, there are ways to customize this project to look at more recent examples of fraudulent emails. But I think the principles of what we want to do remain the same, right? And you'll notice that all of this is completely unstructured. We don't have any information for where email number 1 starts and ends, where email number 2 starts and ends. All we have is just lines and lines of text, right? And so if we were to simply use this as input for any downstream task, there's not much there's not much information that we're providing to our machine learning algorithm as far as identifying individual bits of email is concerned. So it might be a good idea when we encounter a unstructured data dump like this to do some pre-processing on our own end. And Regex is something that we can really use for our pre-processing steps. Right now, you may have noticed again that when we receive an email, some of the relevant portions that the user is seeing would be maybe the from or the return email ID, who is the email being sent to, who is sending the email. We usually encounter the subject. It's usually listed in our inbox, and of course there is the message itself. And so each of these bits of information play different role in helping us identify fraudulent emails, and we might want to separate them out, for example. Right now, is there a pattern in how people structure their subject lines or their email text that can tip us off when to consider a text to be spam or not? So we can look for new line, capitalization, symbols. So in this case, we saw that there's a bunch of emails which are in all caps. There's also, each line has also been separated with more than one new line. That's something that seems to be off. There might be specific words that we might be interested in. For example, urgent, assistance, Nigeria, and a query including the word Nigeria and Prince, for example, a unique opportunity. So any other forms of royalty marking text. So these might be specific things that we're looking for in order to separate out our text, our data of relevance, right? And here's something that we might want to look at. We might want to look at capitalization at the beginning of every single line. We might want to look for headers and colons and space for some of the elements. We might consider looking at angular brackets in order to identify emails. So these are tags that can help us ensure that we're only capturing the thing that we need, right? And something that we might want to consider is locating just the sender IDs to get a sense of where all of these emails are overall originating from, right? So in this case, I have a pattern over here, which is looking for a line that starts with a capital or small f followed by ROM. So we're looking for the word from. We want to see a colon right after it, and then we want to see some text after it. And we're also looking for angular brackets so that we can capture the email ID, right? And that's what the round brackets over here are doing. This helps us effectively extract the email IDs from our from line, right? So if you can try running this and uncommenting the print lines in order to see what it looks like. So I'm just going to print the length of I'm going to print the length of the sender address variable over here to see how many matches it returned. So I got 3,254 matches. And if you'd like to see what the output looks like, you can uncomment the previous line. It's just going to give you a lot of, it's going to give you a big dump. So I'm going to not do that right now. Next is, if you want to actually extract the subject line of the email, what would be an edit that we can make to this previous code chunk in order to, instead of looking for the from line, looking for the subject line, right? So it's a very, it should be fairly easy to do. I'll give you a minute to try this activity out. Very simply, you can copy and paste the code over here, and the only line that you'll need to change is the pattern. And we're looking for the subject line instead of the from line. So yeah, please take a minute to try this out and let me know if you're getting expected results or if something unexpected is happening. All right. So in case you had a chance, do let me know if you were able to create a corpus of subject lines. With this specific activity, we've actually created two data sets. We've created one data set for fraudulent email IDs, and we've created another data set for fraudulent subject names. And now there's two kinds of trainings that you can right away carry out. If you were given a data dump with millions of emails, can you use the subject line in order to identify fraudulent emails? And can you use the from line in order to look for emails and examine if a machine can determine if an email is spam by using the email ID. So just by structuring or subsetting our data a little bit, we've already streamlined our process for other downstream NLP search tasks. Next, if you're interested in looking at the various salutations, if you're interested to see how a fraudulent email starts, an example of a simple search that you could do as you explore this would be to look for the number of times in which an email starts with the words "sir" or "attention." So in this case, in our pattern, we're looking for these specific words, but these can be, but you can tailor this particular expression to look for other forms of email starts, and you can look through your corpus in order to better understand what's happening at scale. Now, in this example, when I run this code, it tells me that there are 2,074 instances of emails containing the words "dear" or "attention." Not surprising, given most of us start our emails with "dear." So, or depending on the context. And so we might want to create a more nuanced search pattern in order to look through and understand what fraudulent emails do. All right. So again, if another thing that makes a lot of fraudulent emails stand out is weird elements, weird characters, random HTML tags. You might see the new line character printed as /n instead of just a new line. There might be strings that contain non-alphanumeric symbols. So there might be dollar signs. There might be like more dollar signs than one might need. There might be percentage signs. So another way to just simply search through our corpus in order to assess what the content is like, you could consider building a simple search query to look for text in all caps, look for HTML tags, etc. And again, this the little loop over here is something that you could modify if you're interested in to look for these specific elements. And like just to give a scope, I brainstormed with ChatGPT to better understand how I could extract the body of an email from my data set. And the regular expression was a little bit more complex than I know how to create. And so this is the pattern and match options that were returned to me. And in this case, I'm looking for a chunk of text in my data set that is contained between the words status and from. So we're looking at the words from, and then we're going down all the way to the word status, and whatever text is between those two lines is being returned as the email body. And this is something that I understood intuitively, and in order to write the regular expression, I got my experience from here. All right, so let's see here. So you can try out this bit of this chunk as well to see if it's giving you expected results. And another thing, because this is a more complex expression, there might be more spurious results than the easy expressions that we use so far. So I invite you to assess if you are able to correctly capture the body of your text. And essentially what this does is you're able to denoise your data and only keep the text, the language of that a person is using in order to write their spurious email, and you're removing all the extra metadata that an email capturing engine provides, right? And this is something, again, consider if you have a corpus with billions of lines of data, this is something that immediately can remove, say, 20% or 10% of your data set, and you're immediately improving the efficiency of your pipeline by filtering out things that you actually don't need for your downstream task, right? So again, there is no end to how many to the complexity of regular expressions that we can use. But the bottom line is that it's a very useful task for pre-processing. It's something that can really improve your metrics if you're building an NLP engine, if you are training your own algorithm, and the most important thing, of course, is that it's not that the compute overhead is very low, and it can really, especially if you're relying on HPC or other cluster systems where you have limitations of how much compute you have, using these simple tools to improve your project can go a long way, right? So I'll leave you with this. Finally, if you're interested in learning more about regular expressions, the Regex cookbook is a fantastic resource which contains all of the information with great explanations. Regex 101 is, again, one of my favorites for making sure that I understand what my regular expression is doing, and I test it before actually deploying. There are other regular expression platforms as well. If you're interested in improving and building on your knowledge, the Regex crossword is a fun activity that in which all of the clues and all of the results are actually Regex terms. There's also beginners guides and like Regex 1, where you have simple interactive exercises that incrementally improve how you work with regular expressions. And finally, if you're interested in learning more about Google search, advanced search operators, there's a helpful link over here that can add to that specific information. So with this, I hope that there are small ways in which you will consider using regular expressions in your NLP pre-processing as well as processing. And if you have any questions, or if you'd like some help ideating your NLP project, or learning more about NLP use cases, or if you'd like any information on any current project that you have, please feel free to reach out to us through the UA Data Science Slack. And I also invite you to check out all of the other workshops that are offered through the Data Lab, and many of them hopefully will work in tandem with the information that's shared here. And most importantly, thank you so much for being here and joining us today.